entity relationship diagrams. This lesson will look at what are entity relationship diagrams, why are they used, what are entities, what are attributes, and what are the relationships between entities. The process of building any application requires that the designer gains a full understanding of the real world, is able to produce a model of the data used, and then use that model as a basis of a logical, workable database design. The data model of concern here is the Entity Relationship Diagram, or ERD. The first stage of any ERD is to try to identify each entity. Examples of entities might be student, who's someone who takes a course at a college, a tutor, someone who has responsibility for coordinating a course, courses themselves, which are courses of study taken by students in the college, and assignments, which are pieces of work given to assess particular courses. An entity name needs to be clear and easily understood. Attributes are the information you need to know about each entity. The example of a student would have a student number, which will uniquely identify that student, a name, an address, telephone number, and course taken. All reasonable items of information that we may want to know about a student. Now, the relationships between entities are all important when designing an ERD, and they represent the associations between each entity. For example, each student may enroll for one or more courses. Each course must be taken by one or more students. These sentences define what the relationships are between courses and students. And there are three things that we need to know about relationships. They are the relationship name, the membership rules, and the relationship degree. And we're going to look at each of those in turn now. The relationship name then describes the context for the association between the two entities. For example, each student may enroll for one or more courses. Each course must be taken by one or more students. The writing in bold there defines what the association is. Each relationship will also have certain membership rules, and these state whether a relationship must exist for an entity or if it is optional. A course, for example, must be taken by a student, otherwise it would not run. No students, no course. The relationship is mandatory. A student, on the other hand, may or may not take a course, so the relationship is said to be optional. So we can say each student may enroll for one or more courses, but each course must be taken by one or more students. There are three possible degrees of relationships. They are one-to-one, one-to-many, and many-to-many. In a one-to-one relationship, an instance of entity A is related to one and only one instance of entity B. In our college example, a course tutor may be coordinator for one and only one course, and each course must be coordinated by one and only one course tutor. This is a one-to-one relationship and can be represented by the notation you see on the screen. One-to-many relationships says that an instance of an entity is related to one or more instances of another entity. For example, each assignment must relate to one and only one course, but each course may be assessed through one or more course assignments. In a many-to-many relationship, an instance of an entity is related to one or more instances of, and vice versa. For example, each student may take one or more courses. Each course must be taken by one or more students. Many-to-many relationships are not supported by relational database management systems and must be resolved into two one-to-many relationships. We will see an example of this later on. As an ERD is a graphical representation of the system, then the relationships must be represented on the ERD by symbols. And both the type of line used and the way in which it connects with the entity symbol are significant. The primary key is represented by the one end, and the foreign key is represented by the many end. Here we see the relationships represented graphically. The top example is a many-to-many relationship, and little arrowhead shapes are known as the crow's feet notation, and they represent the many end of a relationship. In the one-to-many example that we see in the middle, the bar notation on the left hand side represents the one end of the relationship, and we can see this again in the one-to-one symbol at the bottom of the screen. So to show an ERD at work, I'm going to take a system that develops the relationships between authors, their books, their publishers, and their agents. The table that you see on the screen are the rules by which this ERD is going to be created. So we can see that for this system, each book must be written by one and only one author. Each author may write one or more books. Each book may be published by one and only one publisher. And each publisher must publish one or more books. Each author may employ one and only one agent, and each agent must be employed by one or more authors. So the first thing we need to do before we create our ERD is decide what entities are involved in this system. And they are book, author, publisher, and agent. So once we know the entities, then we can work out what the relationships between each are based on the rules above. Here we see a completed ERD. In this example, we can see that a many-to-many relationship exists between book and author. And if we look at the key, we can see that the dashed line denotes an optional membership rule, and the solid line denotes a mandate. So we can see that an author may write a book, but a book must be written by an author. An author may employ an agent, but an agent must be employed by an author, and so on. Inside each of the entities, we can see a couple of examples of attributes of that entity. Book, for example, has book reference and author reference. Book reference in this case would be a primary key for book, and that is represented by the underline. And the author reference is a foreign key, and this is denoted by the star symbol. We can also see that author has author reference as primary key, agent has agent reference, and publisher has publisher reference. It's important to know what the primary keys for each entity are and what foreign keys may then exist in each entity, so that we can understand how each entity is related to each other. Now, as we said before, many-to-many relationships are not supported by relational database management systems, so we must create a bridging entity to get rid of this problem. So we must revise previous ERD by introducing a new entity called bookline, and this is used to break up the many-to-many relationship. So we can see now that there is a one-to-many relationship between author and bookline, and a one-to-many relationship between book and bookline. This schema that has appeared at the bottom of the screen represents each entity and the attributes contained within. This completed diagram will give the system developer a much clearer picture of all the data and the relationships that are to be held within a system, and goes a long way to helping them understand how a new system will be created.